Hello my friends and business partners from around the world, welcome to my channel. In this video, I'm going to speak about the linear DC machine. To see the exercise, go to the description of the video. Here, the voltage of the battery is 120 volts. The resistance of the path is 0.3 ohms. The machine is in a region where the magnetic flux density is 0.1 Tesla. And the separation of the rails in which the moving bar is going to slide is 10 meters. Knowing that, let's solve the exercise. The exercise says in letter A, what is the machine's starting current? What is the steady state velocity at no load? Letter B, deposit a 3 kilograms load on the moving bar and calculate the steady state velocity and the consumed power. Letter C, assume that the bar is unloaded and that it suddenly runs into a region where the magnetic field is 0.08 Tesla. What is the new velocity? And letter D, if a 30 Newton force to the right is applied, what is the steady state velocity? How much power is the bar producing? How much power the battery is consuming? Okay, in letter A, B, C, and D, the machine is going to operate as a motor, and in letter D, the machine is going to operate as a generator. Okay, let's go, let's solve it. In letter A, the exercise asks us to calculate the starting current. So let's calculate the starting current. The starting current of the machine. Okay. At all t, VB equals to R times I plus a int. Alright? We know this, the resistance, we know the voltage of the battery, 120 volts. We need to know the induced voltage. How do we know that? The law of induction says A ind is equal to V cross B dot L. Do you guys get it? But at t equal to 0, the velocity is equal to 0 too. Okay? Then the induced voltage is going to be equal to 0. If the induced voltage is equal to 0, then we can find the starting current to be 120 volts divided by 0.3 ohms, which is 400 amperes. Alright? Do you understand what I say? Okay. Now that we already have the starting current at t equal to 0, we can calculate the other topic. The letter A asks us to calculate the steady state velocity at no load. Okay, at no load, the steady state velocity of this machine. Okay, at no load, we are in letter A. At no load, when is steady state going to be reached? When the acceleration is equal to 0. Okay? We are going to have an induced forces here that's going to drag the moving bar to the right. And when this force is equal to 0, we have the steady state. Okay? The machine is not accelerating anymore. And when this force is equal to 0, how do we find this? We find that the induced voltage is going to be equal to the voltage of the battery. Why? Because it is not accelerating anymore. See that the law of induction says that this is equal to L cross B. Okay? If it is zero, then the current is also zero. The machine is not consuming current. Okay? If the current is equal to zero, then this term here can be neglected. And then we are going to have this. Okay? And the induced voltage is equal to VBL. Alright? And to calculate the velocity, what we need to do is divide the 120 volts by 10 meters and 0.1 Tesla. Okay? And then we find a velocity of 120 meters per second. That's the velocity at no load, at steady state condition. Okay? Are you guys understanding everything? Now let's move on to letter B. Letter B wants us to put a load on the moving bar, isn't it? Yes, let's see. Letter B wants us to deposit a 3 kilogram load on the moving bar. So the mass of the load is 3 kilograms. But we are not going to work with mass, we are going to work with force. So the weight of the load is 3 times 10, 30 newtons. Okay? And this is going to be to this side. Okay? Weight and force is the same. So the load is going to be 30 newtons, and we want to calculate the new steady state. The new steady state is going to be reached when we find that when the new steady state is reached, the acceleration is equal to 0. Okay? The acceleration is equal to 0 because we are in steady state. In steady state, the machine is not accelerating anymore. And when it happens, we know that the induced force, which is equal to I L cross B, has to be equal to 30 newtons. 30 newtons, okay? And if we divide this 30 newtons by 10 and 0.1, we get the current of 30 amperes. Alright, this is the current that the machine is going to consume at steady state. Okay, we are going to use these 30 amperes to calculate the induced voltage. The induced voltage is going to be VB equals to R times I plus the induced voltage. Here we already know that it is 120 volts. Here it is 0.3 ohms. Here 30 amperes plus the induced voltage. And from this we find that the induced voltage is equal to 111 volts. Okay? But this is not yet what we want to calculate. What we want to calculate is the steady state velocity. And how do we calculate the steady state velocity? We are going to use the law of induction for the induced voltage. So let's use it. Let's use the law of induction for the induced voltage. The law of induction says that the induced voltage is equal to V vector B dot V cross B dot L. Okay, and we already found that it is 111 volts. Are you guys understanding? Okay, so due to the geometry of the problem, we can say that V is going to be equal to 111 volts divided by 10 meters, 0.1 Tesla. And this is equal to 111 meters per second. Okay? Very easy, very easy. What we need to do is simply to use the laws of induction. Okay? And the consumed power is going to be P. The consumed power is going to be equal to force times velocity plus resistance times current squared. Okay? Do you guys get me? Okay, so let me use my calculator. I think that this is going to be equal to 3,330 watts plus, I'm gonna have to use my calculator here. You guys please help me with this. We found the value of the current to be 30 squared times 0.3, okay? So it's 270 watts, okay? So now we find that the power consumed by the system to be 3,330 plus 207, which is 3,600 watts. Okay? This is the mechanical power being converted there from electrical to mechanical, and this is the power consumed by the resistive element. Alright? Are you guys understanding everything? Okay, now let's move ahead to letter C. What does letter C want us to calculate? Letter C want us to calculate the new velocity because we want to decrease the field. The field was 0.1 Tesla, and letter C wants us to see what happens when the machine goes to a place where the field is 0.08 Tesla. So what happens? What happens is that there is going to be a new steady state condition. The machine is going to undergo a transient when it goes from 0.1 Tesla to a place of 0.08 Tesla. There is going to be a transient, and after this transient is passed, a new steady state is going to be reached, and then in this new steady state we're going to have this. The velocity is going to be Vb divided by the magnetic flux density times the length of the separation of the rails, and then we simply plug the values here, divided by 0.08 Tesla, 10 meters, and then we find that the new velocity is bigger. Okay? So this is an interesting property of DC machines. If you decrease the magnetic field, actually the machine accelerates. Okay? Very good guys. Now to finish, let's go to letter D. Letter D, machine is going to work as a generator, not a motor anymore. And we want to apply a force. We want to apply a force here. Okay, there is going to be an applied force here. We're going to apply a force there, and we need to know what is going to happen. What is going to happen? So in letter D, the exercise wants us to apply a force of 30 newtons. 30 newtons to the right. How much power is the bar producing? How much power the battery is consuming? And what is the steady state velocity? Okay, let's solve this. Okay, the steady state velocity is going to be reached when the machine is not accelerating anymore. When the machine is not accelerating anymore, we arrive at the steady state. Okay? So the applied force is going to be equal to the induced force, because the machine is going to resist. Here there is going to be an induced force that's going to resist. Okay? The machine is going to resist acceleration, and we find the steady state when these two forces here are equal. When this force is smaller than this force here, we have transient, but when they are equal, we have steady state. And when the steady state happens, we're going to use this expression here, L vector B. Okay? We find that the current, this is equal to 30 newtons. We find that the current for the steady state is going to be equal to 30 newtons divided by 0.1 Tesla and 10 meters, and this is 30 amperes. The current is 30 amperes. And the induced voltage here, that's going to be produced, because we are working as a generator. As you apply a force to that direction, there is going to be an induced voltage here. This induced voltage is not a reaction here anymore. The induced voltage is the voltage that is being generated by the application of this force here. Okay? Alright, my friends, let's go, let's finish the exercise. We are almost over. And then the induced voltage, okay, that's being generated is going to be equal to the voltage of the battery plus the resistance plus the current. Okay, the induced voltage is going to then be 120 volts plus 0.3 ohms times the current. Okay, wasn't it what we calculated? And then we find that the induced voltage is equal to 129 volts. 129 volts. Okay, and the velocity is going to be equal to the induced voltage here divided by L and B. And we find the velocity of 129 meters per second. Okay, my friends. Yes. Very good, very easy. Just use the laws of induction and you are going to understand everything, and you are going to find the same results. And the bar is producing. Now let's talk about power. Let's talk about power, because engineers love talking about power and energy. So let's talk about power, okay? And the bar is producing a power of 129 volts times this current here, which is equal to 3,870 watts. So this is the power that the bar is producing. And the power the battery is consuming is 120 volts, 30 amperes, which is equal to 3,600 watts. So this is the battery. Okay, my friends, this was the video that I wanted to make. I hope you guys enjoyed and understood everything. If you want to talk to me, just leave a message in the comments of the video. And if you want to have a lesson with me, send a message on my WhatsApp. My friends, goodbye!